So far this year, we have talked about linear functions, exponential functions, absolute value functions, and now we're talking about quadratic functions. The learning target 2 that we're going to talk about is I can determine if a set of data represents a linear function or a quadratic function. So we're going to kind of start to compare linears and quadratics. In a graph, it's pretty straightforward because a linear function is a line and a quadratic function looks like a U or an upside down U. In a table, there is a different way besides just graphing it to figure this out. Now, if you look at this, remember to figure out the slope of a linear function, it has to be constant the whole way. So my x is changing by 1, whoops, like that, and my y over here is changing by 8. So because the slope is 8 over 1 the whole way down, that means it is a linear function. It has a constant slope. Now let's try this one. This is going up by 1 each time over here, so far we're good. Now this is changing by, let's see, that's negative 60, negative 52, negative 44, negative 36. So this is definitely not a linear function because it doesn't have the same number right here. It doesn't have a constant slope the whole way. These numbers don't have a same difference in between them the whole way. But now let's take the change of this change. So from negative 60 to negative 52, it's changing by 8. From negative 52 to negative 54, it's going up 8. And from negative 44 to negative 36, it's going up 8. So this is like my first change. This is like my second change, or my first difference and my second difference. If the first change is constant, it's linear, like it is over here. If the second change is constant, it's quadratic, like it is over here. And this second change value, just like how the change over here is the slope, this is we're going to call the A value. And that's going to come in handy in the next few learning targets as we start writing linear functions. Just like the slope is the M, the second change is the A value in a quadratic function. Let's take a look at this one. We're going over here, it's counting up by 1. Over here, it's going up 42. And then it is going up, let's see, 52. And then from 126 to 92, it is going up, let's see, the brain's not working this early. It would be, so that would be 66. And then from 192 to 270, that would be 78. Hold on, that's not 52. That's 54. There we go. So right now we have 42, 54, 66, and 78. That is not linear because it doesn't have a constant change. But let's look at the change in the change. If we go from 42 to 54, that's going up 12. 54 to 66 is 12. 66 to 78 is 12. So the change of the change is constant. So this is a quadratic function. And if I were to write the function, I would make sure that my A value is 12. And we'll talk more in the next week or so about what that A value means and how that relates to the actual writing of the function. But for now, we just know that this is a quadratic function and the A value is 12. Let's look at this one. We go up by 1, 1, 1, 1. From negative 8 to negative 15, it's going down 7. From negative 15 to negative 22, it's going down 7. down 7, and down 7. So because my first change is constant, this is a linear function, and my slope would be negative 7 over 1. So if the first change is constant, we'll call this the first change. It's linear. If the second change is constant, we'll call it quadratic. This right here is the first change. This right here is the second change. It's like the change of the change. And that is how you can tell if a set of data represents a linear or a quadratic function.